Okay, so optimization again. What? I know, super exciting, right? Again, I want to emphasize the importance of this, though, that this is actually very applicable and useful, and it is something that you are going to want to make sure you understand when you get to Calculus BC next year. So we're going to do the other 4 examples on the packet of note problems that I gave you the other day. First one, determine the area of the largest rectangle that can be inscribed in a circle of radius 4. Pause the video. Figure this out. Unpause the video when you're ready to check your work. Okay, so the area of the largest rectangle is 32 units squared. Now, how do we come up with that? Well, first I drew a circle around the origin. I did that so that I have an equation of my circle. You can draw your circle anywhere. I just chose to use the origin because I think it makes the problem easier. In that circle, I drew a rectangle. So I know that this length is 4. So the diagonal of the rectangle is 16. I'm sorry, the diagonal of the rectangle is 8. And then I have these points x, y, negative x, y, x, negative y, and over here I have negative x, negative y. Okay, so first I want to come up with an area equation. Well, I know the length of this side of the rectangle is 2x, the length of this side of the rectangle is 2y, so my area of the rectangle is 4xy. Now I need to come up with another relationship between x and y, and that's my equation of the circle. So if the circle is centered around the origin, then the equation of the circle is x squared plus y squared equals 16 because it has a radius of 4. Now notice that the restrictions on this circle are x is between negative 4 and 4, and y is between negative 4 and 4, including those points. But now when I do a substitution, so I solve this equation for y, I get y is plus or minus the square root of 16 minus x squared, I can ignore the minus because when I substitute in here I don't want a negative area. And so now my restriction on x has become 0 to 4. So I need to use this as my endpoints when I'm thinking about maximums and minimums. One thing I can recognize right away, if x is 0, the area is 0, so that would be a minimum. If x is 4, the area is also 0, so that would be a minimum. So these endpoints are not going to give me maximum values, but I do want to recognize those are my endpoints. It comes into play when I find my critical values. Now I find the derivative. I have to use the product rule and the chain rule. So first I do that, then I simplify, combine like terms to get a rational equation, and my derivative a prime is 64 minus 8x squared over the square root of 16 minus x squared. Find my critical values, so I set the numerator equal to 0 and I set the denominator equal to 0. So when I set the numerator equal to 0, I get x equals plus or minus 2 root 2, and the denominator gives me x equals plus or minus 4. So all of those are my critical values, but now I can ignore the negatives since those will give me negative area, and I can ignore 4 since it's an endpoint and it results in a minimum area of 0. So when I do my increasing and decreasing chart, I'm just going from 0 to 4, and I'm only testing 2 root 2 to make sure that it's a maximum. It comes out to be a maximum, so I say that using my derivative speak. So since a prime of x is greater than 0 on 0 to 2 root 2, and a prime of x is less than 0 on 2 root 2 to 4, at x equals 2 root 2 is a relative maximum. Now remember, what did the question ask me for? The question asked me for the largest area. So I find the actual area by plugging in 2 root 2 to my area equation, and I get the area of the largest rectangle is 32 units squared. Since we don't know the units, we write units. Alright, next one. A rectangle is bounded by the x and y axis, and the graph of y equals 6 minus x over 2. What length and width should the rectangle have so its area is a maximum? Pause the video, unpause me, ready to check your work. Alright, this one's hopefully a little bit quicker and easier. The dimensions for the max area should be x equals 3 units and y equals 3 halves units. So how do we come up with that? Well, if I draw this picture, here's my y-axis, here's the x-axis, here's a rectangle, and here is the line y equals 6 minus x over 2, which is actually just y equals 3 minus x over 2. So I want to recognize that x is bounded by 0 and 6, but it could be 0 or 6, and y is bounded by 0 and 3, but it could be 0 or 3. However, if it is one of those endpoints, then that's going to be a minimum area because it's going to be an area of 0. So My area equation is x times y. Y is 3 minus x over 2, which is the equation of my line, so I substitute that in. Area is x times 3 minus x over 2. Distribute the x, so area is 3x minus x squared over 2. The derivative is 3 minus x. So I find my critical value by setting that equal to 0, and I get x equals 3. Now in this case, I chose to do the second derivative test, so the second derivative is negative 1. So since this is negative all the time, that answers my second derivative test, since a prime of 3 is 0, and a double prime of 3 is less than 0 at x equals 3 is a relative maximum. So my dimensions for the max area should be x equals 3 and y equals 3 halves. I got the 3 halves by plugging 3 back into the equation of the line. Next one. Canvas wind shelter for a beach has a back, 2 square sides, and a top. Find the dimensions for which the volume will be 250 cubic feet, and that requires the least possible amount of canvas. Pause the video, unpause when you're ready to check your work. Alright, so here we should end up with the dimensions for the least amount of canvas are going to be a height of 5 feet, a length of 5 feet, and a width of 10 feet. So now let's look at how I came up with that. So first, here's your picture. I labeled this the width, this the length, and that the height. So if you labeled them differently, your dimensions should hopefully be the same numbers, but you might have different labels for them. So what do we know? Well, we know volume is length times width times height, and we know the length equals the height. So we were given that information. Now, we have some restrictions on these variables, and they're going to be open intervals. So the height cannot be 0, and it cannot be 125. It has to be somewhere in between. The length has to be somewhere between 0 and 125, and the width has to be somewhere between 0 and 250. In this case, since it's a physical thing, we actually have a canvas that we're trying to make. That's why we cannot actually equal the zeros. Now, we also know we're trying to we're trying to minimize, but if one of these dimensions is 0, then I'm not actually going to have a physical wind shelter, so you won't have any volume. So they cannot be 0, because we know that the volume has to be 250. Okay, so that's why these are open intervals this time as opposed to closed intervals on the previous one with the rectangle inside the circle and so on. Okay, so now back to the problem. So volume is length times width times height, so I know volume is width times height squared if I substitute in length equaling height. So 250 equals width times height squared, so width is 250 over height squared. So now surface area is what I'm trying to actually minimize. So surface area is 2 times the length times the height plus the width times the height plus the width times the length based on the picture I have here. So I simplify this a little bit. I substitute in L equals H, so I make this 2H squared plus 2WH, since I have WH, plus W times L, but L is H. Then I substitute in for W, because I'm trying to get everything in terms of one variable, and in this case I'm using H. So I end up with a surface area equation 2H squared plus 500 over H. Great. Take the derivative. I get 4H cubed minus 500 over H squared once I get a common denominator. So first it's 4H minus 500 over H squared. Get a common denominator. I get my derivative. Set the numerator equal to 0, set the denominator equal to 0 to get my critical values. I know it can't be 0 though because that is not within the range of H. So I'm just going to test the 5, but I'm using the restrictions 0 to 125, so I don't want to plug in negative values and I don't want to plug in something super large. In this case it actually won't make a difference, but I just want to keep that in mind. So I see that this is going to be a minimum because it's decreasing, then increasing, so since SA prime of H is less than 0 on 0 to 5, and SA prime of H is greater than 0 on 5 to 125 at x equals 5 is a relative min. So that's how then once I know this, and I'm sorry, this should be an H, not an X. So let's change that to an H. So once I know H is 5, then I know L has to be 5, and then I can plug back into this equation right here to find W. So So if h is 5, h squared is, or 5 squared is 25, 250 over 25 is 10. So that's how we come up with our height is 5, our length is 5, and our width is 10. All of those are feet is the units. Alright, last one. An open box is to be constructed from cardboard by cutting out squares of equal size in the corners and then folding up the sides. If the original cardboard before cutting out the squares is 6 inches by 10 inches, determine the dimensions of the box with the largest volume. Pause the video, unpause when you're ready to check your work. Alright, so here we get some nasty numbers, but we find that the dimensions of the box with the largest volume are 6 minus 2 times the quantity 8 minus root 19 over 3 inches by 10 minus 2 times the quantity 8 minus root 19 over 3 inches by 8 minus root 19 over 3 inches. So, how do we come up with that? Well, first I drew this picture. So remember, we're starting out with a piece of cardboard that is 6 by 10 inches. So I'm cutting out squares from each corner. I'm going to call those dimensions x. So now the base of my box is going to be 6 minus 2x by 10 minus 2x. So my restrictions on x are x has to be greater than 0, otherwise I don't have a box, and it has to be less than 3, otherwise I don't have a box. That's an open interval, so I don't have to worry about checking endpoints. Volume is 6 minus 2x times 10 minus 2x times x. Multiply this out, and we end up with volume is 60x minus 32x squared plus 4x cubed. Take the derivative, and 60 minus 64x plus 12x squared. Set the derivative equal to 0 to find my critical values. And we end up with this nice quadratic of 3x squared minus 16x plus 15, which does not factor. So, I used the quadratic formula. You could complete the square if you want. And it ended up, I got critical values of x equals 8 plus or minus root 19 over 3. So those are my critical values, but 8 plus root 19 over 3 is larger than 3, so it's out of my domain of x. So I just tested 8 minus root 19 over 3. This is a little bit greater than 2, so I tested the values of 1 and 2, and this worked as a maximum. So since v prime of x is greater than 0 on 0 to 8 minus root 19 over 3, and v prime of x is less than 0 on 8 minus root 19 over 3 to 3, at x equals 8 minus root 19 over 3 is a relative maximum. And then I just plugged it into each one of those to actually state the dimensions. So that's where these are coming from. Again, on a quiz, I'd probably have you round to 3 decimal places here because these numbers are nasty. But in this case, you can just leave it like this. That's fine. Don't try to simplify that at all. Okay, so pretty much the same conclusion as before. Again, just emphasizing the importance of this, the organization in your work as well. Notice how whenever I'm going through these problems, I'm drawing a picture if possible. I'm writing down the domain or the open or the interval if possible. Circling my important equations, circling my critical values, trying to keep the work neat and concise and in a nice order. All of that is going to be very important. Again, remember, one of the biggest things in math, once you get to higher level math, is being able to explain to somebody through your writing what you're doing. If somebody can't follow your work, it doesn't help. So, that's optimization. On a side note, if you're wondering what Mr. Rumpf does on days when it's freezing cold and school is shut because it's so cold, this is what I'm doing. I'm having a math party at the Party Palace, aka my apartment.